Hello and welcome to your notes for today. So today we're officially taking notes over the law of conservation of mass. Last week we looked at a couple of demonstrations to help us kind of understand the concept, but today we're going to actually take the notes. So during a chemical reaction, this is just generally what a chemical reaction is. During a chemical reaction, chemical bonds are broken, break, and reform, creating new compounds. Just the parts of a chemical formula. On the left-hand side, we have the reactants. The reactants are what goes in. Yields, that's what this arrow in the middle of this formula is. Yield just means makes or equals. And then products are what comes out. The law of conservation of mass says that during a chemical reaction, matter, or you might say mass, is neither created nor destroyed in a chemical reaction. The mass of the reactants must be equal to or the same as the mass of the products. So count the atoms for each compound in this equation. So for CH4, we have one C, 4 H's. For O2, we have 4 O's. For CO2, we have 1 C and 2 O's. And for 2H2O, we have 4 H's and 2 O's. If we add up everything on both sides, we have a total of, I'm going to do this down here. So on this side, we have 1 C, 4 H's, 4 O's, and we have a total of 9 atoms. On the right-hand side, we have 1 C, we have 4 H's, and now notice that we have oxygen in 2 different places. So O is 2 plus 2 equals 4. And again, if we add all of these up, 1 plus 4 plus 4, our total is 9 atoms. So we should notice, sorry that was cut off, we should notice that it's the same on both sides. Wow. Draw a picture of what this reaction looks like. So if you look in the slides, this is there, but I'm also going to draw it right here. So for CH4, there's 1 carbon atom with 4 hydrogen atoms on it. I'm going to kind of put a little crosshatch on the H's, plus 2 O2. This is the formula that we're drawing up here. 2 O2. So that means we need 2 oxygens. And I have a blue pen that I'm going to use to shade in my oxygens. You don't have to use the different colors if you don't want. Yields or makes CO2, so 1 carbon with 2 oxygens on it, plus 2 H2Os. So that's an oxygen in the middle with 2 hydrogens on each side. So how does this picture show that mass is conserved from the reactant side to the product side? Well, we have the same number and type of atoms in a different arrangement. So the law of conservation of mass can also be used to talk about the actual mass or weight of the products in the form of a word problem. Now what you need to remember is that the mass of the reactants must equal the mass of the products. So I have a word problem. I have 16 grams of CH4. Now remember back when we were doing math in our physics unit where we had to circle any number that we have been given. So I'm going to add that we underline and circle whatever thing it tells us that we have the mass of. So I have 16 grams of CH4, 64 grams of O2. So it reacts completely with 64 grams of O2. And we're looking for the mass of the products. So they give us 16 grams and 64 grams. And they want to know what is the total mass of the products. So think of, we said back here on this page that this yield sign is essentially an equal sign. And then what do we have here? A plus sign. So think of this as a math equation. So 16 grams plus 64 grams equals, so think of this arrow as an equal sign, equals some total mass. It's not asking us for CO2 or H2O. It's asking us for the total mass. So we are essentially, for this question, just being asked, what is 16 plus 64? So the total mass of products is equal to 80 grams. Which is 4 plus 6 is 10, carry the 1, 1 plus 1 plus 6 is 8. So 80 grams. So let's look at this one here. If 32 grams of hydrogen, that's this right here, reacts with 128 grams of oxygen, how much water is formed? So this is going to be done the same exact way as this one. So it gave us 32 grams of hydrogen plus 128 grams of oxygen equals some amount of water. So we're just going to do 32 plus 128, which is going to give us 160. So down here, if 8 grams of hydrochloric acid, that's HCl, reacts with sodium and 22 grams of sodium chloride and 9 grams of hydrogen form, how much sodium was used? So this one's a little bit more complicated. So they gave us 8 grams of hydrochloric acid. So I'm looking, hydrochloric acid is this one right here, so I have 8 grams. Plus, they did not give us the amount of sodium. In fact, we're trying to find how much sodium is used, equals 22 grams of sodium chloride. So sodium chloride right here, plus 9 grams of hydrogen. So here we have a equation. And now if you're looking at this, you might say that it's similar to some questions that you might see in your math classes. In math, if we're not sure what a number is, we use a variable. And usually we use the variable x. So we can rewrite this equation so that it's 8 plus x equals 22 plus 9. And we're trying to solve for this x here. Now, if you are not doing this in your math class and you're not familiar with it, then this might be a little bit confusing, but the process is going to be the exact same every time. You want to get this x by itself. And to get x by itself, you need to do the opposite operation of whatever is on the same side as your x. You want to get the x by yourself. So we want to move this 8 over to this side of the equation. So to do that, we need to, since we're adding, we need to subtract 8 on both sides. So we're going to go minus 8, minus 8. That is going to cancel out this 8 on this side, and that's just going to give us x is equal to 22 plus 9 minus 8. This you can just put into your calculator. 22 plus 9 is 31, minus 8 is 23 grams. And you could test this out by plugging this number back in, saying, okay, 8 plus 23 is equal to 31, and then 22 plus 9 is equal to 31, because they need to be the same on both sides. If you're given a multiple choice question and you're not sure how to do this math, just plug numbers into this question mark until you get the correct answer on both sides.